Hey everybody. So haven't been able to go over odds ratios as much as I'd like, and now with class being canceled and not being able to cover it in class today, I just want to make a video that hit home a couple of points for odds ratios that hopefully will be able to help you as you're finishing up your homework and for the quiz that we're going to have next week. So I made this quick PowerPoint that I think is really going to help you, especially on that last problem on your homework about asbestos exposure and what I'm looking for there. So in class, we've often used our 2 by 2 table to compare exposure with disease, but we know our world is a lot more complicated than that, rather than just the binary examples that we've used of exposed and non-exposed. And so oftentimes there's going to be a gradient of exposures. So we can think about comparing those that do not exercise to those who exercise 3 days a week and to those who exercise every day. And so this would be a little different than just looking at exposed and non-exposed, but rather we're actually looking at different levels of exposure. We can also think about something continuous like age. Now we can break down age into a binary, so just have younger and older groups, but that doesn't give us a very good picture of what the risk of age would be. Just kind of grouping everyone together like that. So we may want to have smaller categories so we can look at the risk of each of those different levels. And so we get our odds ratios by cross multiplying the 2 by 2 tables that we use in epidemiology. And we can do that even if we have these gradients of exposures, um, as long as we're using the same referent or non-exposed group and we have them in the bottom row when we perform this calculation. So let me just give you an example here of this table. So this is looking at the risk of age on visual impairment. And so I have here that we're going to use the age 40 to 49-year-olds as our referent groups that are going to be considered our non-exposed. And what I'm looking for is what's the odds ratio for each of these different exposure groups compared to the 40 to 49-year-old age group. And so the way you're able to get this when your table is set up like this, which is much larger than a 2 by 2 table, is you can just construct a series of 2 by 2 tables to be able to calculate your odds ratios. So for example, if I want to look at the odds for the 50 to 59-year-old group, then I can construct a 2 by 2 table with the 50 to 59-year-old row on top, so they would be my exposed group, and the 40 to 49-year-old group would be the non-exposed, so they'd be my bottom row. And I'm just doing that for each different age category. And so I can construct now the rest of this table just by constructing these series of 2 by 2 tables. So what I encourage you to do now is to pause the video and see if you can fill in the odds ratio table that is on this slide here, constructing those series of 2 by 2 tables, and see what kind of odds ratios you get. Okay, so hopefully you paused the video and you were able to fill in this table, and your results should look something like this. So you'll notice on that first row that we have an odds ratio of 1. And so we know from our last class that an odds ratio of 1 means that there is no association between that exposure and that disease. So you might see this sometimes in epidemiology literature or something like that, of an odds ratio of 1 in this top row. And what that's really saying is that it's comparing the 40 to 49-year-old group with itself. And so in comparing that group to itself, we're always going to get an odds ratio of 1. And so now as you'll go down the table, you see the odds ratios start to increase. So increase very slightly in the next row of 1.08, and then start to increase a little bit more with each age group that we go down the table. So I think there was a little bit of confusion in last class on exactly how to interpret these odds ratios, and I want to just make it just a little bit easier. So what I'm really concerned with your interpretation is that you understand that what an odds ratio that's less than 1 means, an odds ratio of 1 means, and an odds ratio greater than 1 means. So we see that all these odds ratios are greater than 1. So what we could say is that visual impairment is greater for the older age groups than for the 40 to 49-year-olds. And so the other thing I want you to be able to see is that, as an odds ratio increases, that's going to mean that the risk is also increasing. And so if we go to this last question, so what do the odds ratios mean for the association between age and visual impairment? So we have a series of really 4 different odds ratios. And so what do each of these odds ratios mean then for this relationship between age and visual impairment? So what trend do you notice in the odds ratios? And we've already kind of talked about that. But I want you to think about what you know about odds ratios. And as you're seeing that it's increasing, what does that mean for the association between age and visual impairment? Does it strengthen the argument that age is a risk factor for visual impairment, or does it not? So those are the kind of things that I want you to think about as you're filling in this table, and through the next few weeks as we start to um, make things extended a little bit beyond just exposed versus non-exposed and expanding beyond that binary. So hopefully this video helped, and feel free to send me some emails if you have any questions as you're going through your homework.